All right, let's dive in. Today, we're going to tackle a skill that's right at the heart of algebra, solving linear equations. Now, I know it can seem like a total mystery, but trust me, by the end of this, you'll see it's really just a puzzle with a clear, logical path to the answer. So where do we even begin?
Well, what if I told you that solving any equation is kind of like peeling an onion? Seriously, an onion has all these layers, right? And you peel them away one by one to get to the very center. That's exactly what we're going to do with math. We're going to systematically peel away the layers of operations to find that answer hiding right in the middle.
So first things first, let's talk about the mission. Before you start peeling back any layers, you have to know what you're looking for. And in pretty much every equation, there is one main goal, one single thing we're trying to do.
And that mission is to find the value of that variable, which is usually an x or a y. Just think of x as a little mystery box with a secret number inside. Our entire job is to figure out what that number is by getting that box all by itself on one side of the equation.
Now, the key to this whole thing, the thing that makes it all work, is remembering that an equation is like a perfectly balanced scale. You know, the old school kind. The equal sign is that pivot point right in the middle. So if you do something to one side, you have to do the exact same thing to the other side to keep it perfectly balanced.
This brings us to what I call the golden rule. It's really just a simple three-step process. First, you look and see what's happening to your variable. Is a number being added to it? Multiplied by it? Second, you do the complete opposite. So the opposite of adding is subtracting. The opposite of multiplying is dividing. And third, and this is the big one, whatever you do, you have to do it to both sides. No exceptions.
Okay, but what happens when there's more than one thing going on? How do you know which operation to undo first? Well, this is where our secret weapon comes in. This is the master key that's going to unlock almost any linear equation you come across.
As the folks over at Ultimate Algebra put it, the key is simply doing the order of operations backwards. It sounds so simple, right? But believe me, this idea is incredibly powerful.
You probably remember learning PEMDAS in school, right? Parentheses, exponents, and so on. We use that to simplify expressions. Well, to solve an equation, we just flip that whole thing on its head. We start by undoing any addition or subtraction, then we handle any multiplication or division, and we work our way up the ladder. This right here is our roadmap.
Okay, let's put our roadmap to the test. Let's take a classic two-step equation. 2x plus 3 equals 9. So looking at our reverse PEMDAS rules, it tells us we have to deal with any addition or subtraction before we can touch that multiplication. That means the plus 3 has to be the first thing to go. So to get rid of a plus 3, what do? The opposite. We subtract 3. And of course, remembering our golden rule, we have to do it to both sides. So on the left, the plus 3 and minus 3 just cancel each other out. On the right, 9 minus 3 gives us 6. And just like that, we've peeled back the first layer of the onion.
Now we're left with a much simpler problem. 2x equals 6. The x is being multiplied by 2. Well, the opposite of multiplying is dividing. So we divide both sides by 2. The 2's on the left cancel out, and 6 divided by 2 is 3. And there you have it. We did it. We isolated x. The secret number in that box was 3 all along.
All right, so that's the basic game plan. But, you know, equations can get a little trickier. And when things get more complex, a few common traps can pop up. Let's take a look at how to spot those traps and, more importantly, how to avoid them. Okay, check out this common mistake. Let's say we have the equation 4m plus 12 equals 8. A really frequent error is that people try to divide by 4 right away, but they only apply it to the 4m part. As you can see here, doing that completely throws our scale out of balance.
So can you see the problem? The golden rule isn't just do it to both sides. The real rule is do it to the entire side. That operation, whether it's division or something else, has to apply to every single piece on that side of the equal sign.
So here's how you actually do it. You have to divide the whole side by 4. So 4m divided by 4 becomes m, and 12 divided by 4 becomes 3. That leaves us with m plus 3 equals 2. From there, it's easy. We just subtract 3 from both sides, and we find out that m equals -1. See the difference?
So, to build some really good habits, here are 4 quick tips from the experts at MathU. 1. Write down all your steps. It really helps you catch mistakes. 2. Brush up on your positive and negative numbers. A simple sign error can mess everything up. 3. Like we just saw, always act on the entire side. And finally, if you ever get stuck, just go back to your roadmap. Reverse PEMDAS. It won't let you down.
So far, we've been dealing with one equation and one mystery variable. But what happens when you have 2, or 3, or even more variables all tangled up together? Well, for that, we need something called a system of equations.
Now, when problems get really complex, writing out all the equations can take forever. So, mathematicians came up with this brilliant shorthand called a matrix. They just take all the numbers next to the variables, the coefficients, and arrange them in a grid they call matrix A. The variables go into matrix X, and the answers go into matrix B. It condenses this whole messy system into one clean, simple equation, AX equals B.
These matrices basically act like a visual map of the entire problem. For really complicated systems, like the one you see here, mathematicians can apply a series of rules, kind of like our golden rule, to systematically simplify these rows of numbers until the solution just pops out.
And here's the amazing part. Using this matrix system, we can solve for all our variables in one super elegant step. You know how division is the inverse or opposite of multiplication? Well, matrices have their own special kind of inverse. And by using this inverse of A, we can isolate X in one go. You don't need to worry about how to calculate it right now. Just know that it's an incredibly powerful shortcut that engineers and scientists use all the time.
Okay, this is it, the final frontier for a lot of people. How do we take all these number crunching skills and actually use them to solve real-world word problems? The secret really is all about translation. The team over at Effortless Math has this fantastic 5-step guide. First, just read the problem. Don't do any math, just understand the story. Second, figure out what you don't know and call it X. Third, and this is the key, translate the English sentences into a math equation. Fourth, use all the skills we just learned to solve for X. And finally, and this is so important, answer the actual question in a complete sentence. Don't just write X equals 5.
And that brings us to the end. We've gone all the way from the simple goal of getting X by itself to tackling complex systems and even real-world problems. You see, this isn't just about passing a math test. It's a fundamental tool for logical thinking. So the real question I want to leave you with is this. Now that you know how to find the unknown, what problems out there in your world are you ready to solve?